2019. Consider two concentric spherical metal shell, that is, it is conductor of radius r1 and r2. The outer shell has charge q. The inner shell is grounded. What is the charge in the inner shell? So first of all, let us consider that the sphere is not grounded. Okay, inner shell is not grounded. So what will be the case? The plus q charge is given at the outer shell, so it will go on the surface of the shell according to the property of conductor. Now if we don't ground it, then there will be no charge in the inner shell, because here already the net electric field inside the conductor is 0, as the charge distribution is uniform. So no charge will be there. Okay, now if we ground, then what will be the ground the inner shell, then what will be the case, that we will discuss. Now according to the question, we ground the inner shell. So first of all, we know that if we ground in any surface, then at that surface V will be 0, potential will be 0. Now first of all, see, without ground, if there any potential at this surface. First of all, let us see. So V will be 1 by 4 pi epsilon naught. Here we consider a Gaussian surface here. So in the Gaussian surface there will be no charge. So Q plus outside the Gaussian surface is Q divided by R2. So we have seen that without grounding, here in the inner shell there will V not equals to 0. So if we ground, then there will be, we have to make V equals to 0 in this surface. Now what will happen? Now let us consider, we have to bring some charge here. Here will be minus q charge will come if we ground this. Okay, so let us consider plus q charge came, q dash charge came here, but later we will see that q dash charge is actually minus. That will give according to the calculation. So let us consider q dash charge will came. We don't know what is the actually it will be minus, but let us consider this plus. So what will happen? This charge will be distributed in the surface. So plus q dash. Okay, now here it is air field region. Here electric field will be generated, and this is also in outer shell is also what, conducting shell, so E will be 0. So somehow it had to make the electric field 0. So here minus q charge will be there in the inner surface of the outer shell. So this is minus q dash. Now as due to this due to this the outer shell will not be any new, it will be just like the before. There will be what charge, then after also there will be same charge, so it there will be new, for making it neutral there will be plus charge. The plus q charge which was given in the before in the outer shell will be reside on the shell also. It was given in the outer shell as that, so that's why. So this is the distribution. Okay, so let us calculate V, what charge inside the shell. Now we know V at r equals to r1 will be 0. So let us find V what will V at r equals to r1. First of all, consider a spherical Gaussian surface here. So inside the surface there will be no charge, so 1 by 4 pi epsilon naught, no charge. And outer the surface, no sorry, we consider Gaussian surfaces r equals to r1. So what will happen, q dash charge by r1 plus, in this outer shell, as the thickness is 0, so actually we calculate the total charge divided by radius. Total charge is this is minus q dash, and plus q dash charge will be induced also. So total charge will be q dash minus q dash plus q divided by radius is r2. This is r2, right? So this will be 0. So now find q dash. Q dash will be r1 q by r2. This is the result. Okay.